The scariest cloning experiment did not end with a monster. It ended with a generation that could not survive. After 20 years, 57 generations, and almost 1,200 cloned mice, the mice in the 58th generation were born, then quickly died. That is not how people imagine cloning going wrong. You think the scary part is that cloning is too powerful. Powerful enough to copy a pet. Powerful enough to bring back a mammoth. Maybe even powerful enough to copy you. But the real limit is almost the opposite. The problem is not that cloning can do everything. The problem is that it cannot keep doing the one thing we secretly want from it. It can sometimes create a new life from old genetic material. But can that life keep producing another generation, again and again, without nature stepping in to reshuffle the deck? That is where the fantasy starts to crack. In 1996, Dolly the sheep was born, and the world paid attention. News shows talked about her. Textbooks talked about her. Scientists talked about her. And ordinary people started asking the question science fiction had trained them to ask. If a sheep can be cloned, can a dog be cloned? Can a cat? Can an extinct animal? Can a person? The attraction was never just the laboratory trick. It was the feeling that life might have a backup copy. If the genes are still there, maybe the living thing can come back. If the code survives, maybe loss is not final. And for a while, cloning seemed to move in that direction. Cloned cattle appeared. Cloned cats. Cloned dogs. Cloning attempts involving endangered animals. From the outside, the technology began to look less like a shock and more like a tool. But one question did not go away. Dolly lived only 6 years. Late in life, she had arthritis, and she was eventually euthanized after developing lung disease. Scientists did not prove that Dolly died because she was cloned. That distinction matters. But Dolly left behind a harder question. Can cloning create a living animal? Yes, under the right conditions. But can it keep a lineage going? That is a different question. A team at the University of Yamanashi in Japan tested that question in an extreme way. They began with one healthy female mouse. They cloned the first generation. Then they used body cells from that first generation to clone the second. Then cells from the second were used to clone the third. No natural mating. No new genetic mixing. No ordinary reset. Just cloning from clone to clone, generation after generation. In plain terms, they were asking, if life is only copied, how far can a clone line go? At first, the answer looked almost too good. Many early generations of cloned mice appeared healthy. Their lifespans were close to ordinary mice. For a while, cloning efficiency even improved. That is the trap. When the first copies look clean, you start to believe the whole process is clean. You start to imagine that reproduction may not need nature's messy system. 2 parents, chance, mixing, selection, and failure. Maybe a body can simply be repeated. Maybe a bloodline can become a straight line. And if that is true, cloning is not just a technique. It is a shortcut around one of the oldest rules of life. But the trouble came later. After more than 20 generations, the pattern changed. The success rate began to fall. More embryos developed abnormally. More birth defects appeared. By generation 57, the birth rate had fallen so low that the line could barely continue. By generation 58, the mice that were born quickly died. So the experiment did not just ask whether cloning could work once. It asked whether copying alone could do the job that reproduction normally does. And the answer, at least in that mouse line, was no. That is why the result feels bigger than a lab problem. It is a question about what life needs in order to keep going. It did not just expose a technical limit. It broke the fantasy people wanted cloning to prove true. We often assume the real barriers around cloning are ethics, law, cost, or public fear. And those barriers are real. But this points to a deeper one. Life does not behave like a file that can be copied forever. Think of a photocopier. The first copy may look clear. The second still looks usable. The third may have only one tiny dark spot. But if you never go back to the original, and every new copy is made from the last copy, the flaws travel forward. The dark spot stays. The blur stays. The fold stays. Each round keeps old flaws and adds new ones. At some point, the page is not destroyed all at once. The message just starts to disappear. Cloning is more complicated than a sheet of paper, but the warning is similar. Each generation may still resemble the animal before it, but it is not getting the fresh start reproduction gives each generation. It can carry forward problems already sitting inside the previous cells. And the next round of copying can add more errors of its own. For a few generations, small problems can hide. A living body can absorb a lot before anything looks wrong. But across a copied lineage, hidden damage does not vanish. It travels forward, and eventually, the next generation pays for it. That is why the frightening image is not one sick, cloned animal. It is a whole line of life slowly losing its future. Not a sudden explosion, not one obvious curse, just a narrowing path, generation after generation, until the next generation can no longer survive. So why has nature not collapsed the same way? The plain answer is sexual reproduction. The phrase sounds ordinary because it is so common, but it is also one of life's great reset systems. Sexual reproduction does not simply copy the father. It does not simply copy the mother. It recombines two sets of genes. It breaks some risky combinations apart. It blocks some dangerous combinations before birth. It gives the next generation a different starting hand. That does not mean nature is kind. Nature wastes enormous possibilities. Most possible lives never happen. But that mess has a function. Change, mixing, and selection prevent life from becoming one long chain of copied damage. The mess is part of the protection, and that changes what cloning really is. Cloning has not disappeared. It can still matter in biological research. It may help protect some endangered animals. It can be used in stem cell medicine, biopharmaceutical work, and agricultural breeding. But it is not the thing our imagination wanted it to be. It is not an immortality button. It is not magic that runs death backward. It is powerful, but its promise is narrow. Under certain conditions, it can copy genetic material and help produce a new individual. But it cannot copy the whole history that made a life feel irreplaceable. And that is the part people almost never say out loud. When we dream about cloning, we are usually not dreaming about DNA. We are dreaming about a dog looking at us the same way again. A cat curling into the same corner. A person we lost walking back into the room. A version of ourselves that did not age, fail, choose wrong, or disappear. But a life is not only a genome. It is also the time it was born into. The body it grew inside. The accidents it survived. The habits it learned. The people it trusted. The choices it made before anyone knew those choices would matter. Those things are not stored inside a cell nucleus waiting to be copied again. Cloning can copy genes. It can copy a body plan. Under the right conditions, it can produce an animal that closely resembles another. But it cannot copy a life that has already been lived. That is the most counterintuitive thing about cloning. It looks like a way to defeat nature. But when pushed far enough, it shows how hard nature is to bypass. Life made it this far not by staying perfectly the same, but by being reshuffled, tested, damaged, repaired, and reshuffled again. That is why the cloned lineage ending at generation 58 feels so strange. It is not just about mice. It is about the hope you carry whenever you wish something lost could simply come back. The hope that enough technology might undo time. The hope that a perfect copy might make loss less final. But copying is not the same as returning. You are not a file. No one you love is a file. And whatever cloning can copy, it cannot make a life happen twice.